Hello everyone, I am Shashwat Saxena, 22MIS0047, and welcome to this presentation on the facade pattern, a design pattern that simplifies complex code by creating a unified interface. Imagine this, you are in charge of managing the entire electrical system of a massive skyscraper. Each floor has its own unique wiring setup, and every light, outlet, and device has its own control. Now, instead of going floor by floor and figuring out which switch controls what, you have a central control panel that simplifies everything. This would make everything more easier to work with. The facade pattern acts like the control panel in software. It provides one simplified way to interact with complex systems. Today, I will take you through the core idea behind this pattern, how it helps in reducing complexity, and the various way it can be used in real-world scenarios. By the end, you will understand how this pattern makes system easier to use, maintain, and extend. Introduction to facade pattern. The facade pattern creates a single point of access to a complex system. Imagine an airport, a place with numerous services like baggage handling, security checks, ticketing, boarding, and many more. If you, as a passenger, had to deal with each and every service separately, it would be overwhelming. But with an airport app or terminal, all your needs are handled through one system, whether it's checking in or booking a seat. This is a real world example of how facade pattern works. In software, facade hides the complexity of multiple subsystems and provide a simple single interface for the client to interact with. It's especially useful when you have a system with many interconnected parts, but you want to make it as user friendly as possible. This pattern is perfect for large systems, where user only needs to see the high level functionality without getting involved in the intricate working of the individual subsystems. Intent of this pattern. The facade pattern is invaluable when it comes to reducing complexity. In large-scale applications such as enterprise software, multiple subsystems handle different tasks like database management, security, and user interface. For instance, consider an inventory management system. There might be separate subsystem for tracking stocks level, reordering supplies, managing shipments, and invoicing to the customer. Without this pattern, a user or developer would have to interact with each of the subsystems individually and separately, making the system overwhelming and unusable. But by introducing a facade or a common interface, a single simple interface, all of these operations can be accessed through one simplified way. Another example we can think about is a cloud computing platform, where the system must handle storage, computer resources, and networking together. This facade provides developers with a simple interface to deploy application or manage infrastructure, while the platform handles the heavy lifting in the background. The facade pattern provides a easier way for users to work with these cloud computing software. This simplification reduces not only the complexity for the user but also the likelihood of errors, making the overall system more reliable and easier to maintain. Now we will take a example of smart healthcare system. So let's dive in. Modern hospitals are equipped with multiple subsystems like patient monitoring, medical tracking, scheduling, diagnostic, pharmaceutical, and many more. These systems need to work together, but it would be an overwhelming process for hospital staff to manage each and every system independently. In this case, we can use a pattern like facade, which can act as a central interface and allow doctors and nurses to access patient information, review medical history, monitor real-time healthcare data, and order medication all from one dashboard. This dramatically simplifies the interaction with multiple medical systems, while behind the scene, this facade pattern coordinates the different subsystems to provide a seamless experience. Without this pattern, the hospital staff would need to interact with each and every system individually, increasing their workload and potential for mischief. This type of simplified interaction is crucial in fast paced environments like hospitals and many more areas. Now we will talk about the applicability of this software and how is client interaction done with facade pattern. We will take the example of a hotel management system. Running a hotel involves many risks, and it involves many tasks also. Example, room reservation, housekeeping, billing, guest services, and many more. Instead of managing each task through a separate interface, the facade pattern simplifies everything by offering one interface for all hotel operations. From this single interface, the hotel staff can manage guest check-ins, update room availability, and assign housekeeping duties and generate bills. For the staff, this central system drastically simplifies operation, especially in large hotels, where multiple departments must work in sync. From a software perspective, this also makes the code cleaner, easier to develop, and more modular since each subsystem operates independently under the hood. This shows how a single facade can simplify and streamline interaction between user and various subsystems, ensuring a smoother work. In hotel management, the facade is also like a receptionist who does all the user needs without interacting with all the other subsystems. So now we will talk about the collaboration in facade pattern. So one of the biggest advantage of facade pattern is that it provides and promotes weak coupling. This means that the various patterns of the system don't really rely heavily on each other, making the system easier to update, scale, and modify. A great example of this scenario is a video streaming platform. A service like Netflix, YouTube, or Twitch has multiple subsystems working together, like video encoding, content delivery, recommendation algorithm, and user management. When a user logs in and watches a video, the facade ensures they don't interact with the subsystem individually. Instead, they just use the platform to browse and play content, while the facade handles the interaction with the underlying subsystems. If Netflix want to update its recommendation system without affecting other parts of the platform, the weak coupling enables and ensures them to do so easily. And this is only possible because of the facade pattern. The facade decouples the client experience from the internal operation, allowing each part to evolve independently and separately. So now we will talk about the consequences in facade pattern and the challenges in implementation. While the facade pattern offers many benefits, there are also many challenges to consider during implementation. Take the example of financial system, which involves multiple sensitive subsystems such as banking, loan processing, and credit scoring. One of the major challenges is deciding which subsystem functionality should be exposed to client through the facade. You want to offer enough functionality to make the system useful, but at the same time you need to protect sensitive operation from being accessed directly. Another challenge is overloading the facade. If the facade tries to handle too many responsibilities, it can become a bottleneck in the system. For example, if a facade in financial system tries to handle both customer interaction and internal processing, it may slow down the entire process. The goal is to keep the facade focused on its primary task, simplifying user interaction while leaving the heavy processing to the subsystem themselves. These challenges highlight the importance of designing the facade carefully, ensuring it balances sis- simplicity with functionality and doesn't become a performance issue. Now we will take a real world applicability example of automobile industry. The facade pattern is widely used in various industry, and one area where it's especially relevant is the automobile industry. Modern cars are loaded with technology, There are systems for engine control, braking, entertainment, and navigation. Each of these systems could be complicated to manage on its own, but with a centralized dashboard interface, the driver interacts with all of them using a simple user-friendly interface. This is an example of how the facade simplifies the experience. For the manufacturer, the facade also makes it easier to upgrade individual system without affecting the overall functionality of the car. If the navigation system needs an update, it can be done without changing the driver interaction with the car, and the driver wouldn't even know which part of the subsystems are changed. In the automotive world, where safety and reliability are critical, the facade ensures the driver gets a smooth, intuitive experience without being bogged down by the technical complexity of the car's internal system. So now, to summarize, the facade pattern is a powerful design tool for simplifying interaction with complex systems. Whether we are talking about healthcare, finance, video streaming, or the automotive industry, the facade provides a single unified interface that reduces complexity and improves user experience. There are many more industries where this pattern can be used and is being used. By using this pattern, we are not only simplifying the client interaction, but we also promote weak coupling, making our system more flexible and easier to maintain. However, careful consideration must be given during its implementation to avoid overcomplicating the facade or exposing too much subsystem detail, like we talked about in the financial system. Ultimately, the facade pattern is about making systems easier to use and manage, which is essentially today's fast paced, technology driven world. Thank you for your attention.